In this video, we are going to talk about the least squares regression line. So up to this point, we have talked about scatter plots, we have talked about associations and the R value, but we haven't talked about the line, which is really kind of the whole point here, is being able to draw this line that describes our data. So here we obviously have a scatter plot that has a moderately strong positive linear association, and the R value is given to us at 0.76, and 0.76 is not incredibly strong, but my question is, where did this line come from? How did the computer program that I used know where the line should be drawn? Could I just come in here with a straight edge and a pen and say, well, I think it should look like this instead? Well, let me explain to you how a computer program finds the least squared regression line. The least squared regression line, again, that's this line going through our data, is made up of all of the points x, comma, y hat. So this is the line y hat equals something. And the hat just tells us that it's a predicted value. So here's why this is important. This yellow line is talking about my predicted value. So let's say here's a point here that's a predicted value for x, but notice here is the actual value for x. So there are a few points, like look at this guy right here, where my predicted value and my actual value are pretty much the same, and that's great. But what the computer does is it finds all of the residuals, and this is why we do not do this by hand. It takes every single one of these many points and finds the residual, which means it takes the actual value and subtracts the predicted value. So again, this is actual minus predicted. And points above the line obviously have a positive residual, and below the line have a negative residual. So this line here would represent a negative residual because our value, our actual value, is below what we expect based on our least squared regression line. So what does all of that with residuals have to do with the least squared regression line? Well, that's how our computer program finds this line. What it does is it takes all of the residuals for all of the points and it squares them, which of course makes them all positive, and finds the sum. And our line of best fit, which is the least squared regression line, is where whichever line where the sum is the smallest, and that is why it's called the least because it's the smallest, squares because we're squaring it, and then regression line because it's obviously linear regression. So again, we've all taken algebra before we've come to this class, and so we know and are very familiar with the slope-intercept form in algebra, y equals mx plus b. In statistics, we make a couple of changes to this. The first thing we do is we change the order. So we put the b first, which is of course the y-intercept. And then we put the m times x second. M equals slope. And then we're going to use a hat. So again, we talked about the hat, and the hat here denotes that this is a predicted value. And the reason that it's not okay to just use y is because the predicted value and the actual observed value are not always the same. In fact, most of the time they are not the same. So the y hat denotes that we're talking about a value that is predicted, that is on the line that we came up with. We also change b to b sub 0, and again that's still the y-intercept, and then we change m to b sub 1, which represents the slope. And lastly, we replace y and x with variable names. So this would be whatever the response variable is, of course whatever the y variable is, and this would be whatever the x variable is, or the explanatory variable. So if I took all of this data and I took it to Excel and asked it to do the regression equation, my output would look like this. and the output, notice, is in the typical slope-intercept form. If I asked you, and I will, how to write that in the proper statistical form, what I would do first is say that y is a fat value, and so notice here I've replaced y with fat hat being the predicted fat content. Then I would switch the order of these two, so I'm going to put 8.4 first, 9.1 second, and instead of x, I'm going to write the x variable name, which is protein. And you can certainly put protein in grams if you want to be super specific, and fat in grams, but I used fat and protein because those were the two variable names.